Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we were discussing about the synthetic application of ethyl acetoacetate, and as we know that near about there are 9 applications we have discussed. By using ethyl acetoacetate, we can prepare number of organic chemistry, number of organic compound in the laboratory that we have discussed, and there are some of the steps you should remember while synthesizing the target molecule by using as a ethyl acetoacetate. Ethyl acetoacetate is a active methylene compound. Why it is active methylene compound? Because it has or it possesses the active methylene compound, active methylene group CH-2. Active methylene group means what? Or this CH-2 group is called as active methylene group. When it is called as active methylene group? Because when this CH2 group is located between two strong electron withdrawing group, then and then we can call it as a active methylene group, and such compound are generally termed as reactive or the active methylene compounds. So one of that compound, how it is prepared, how it is synthesized in the laboratory, which is the named reaction involved in it for synthesis of that, the full description about that we already discussed in our previous lecture, and today we are going to discuss about the second active methylene compound or the reactive methylene compound. The name of the second active methylene compound or the reactive is a DEM. DEM means a diethyl malonate or malonic ester. Now first we are going to discuss why this compound is called as an active methylene compound, how it is prepared in the laboratory, what are the starting material, what are the suitable reagent, and what is the appropriate or condition used for the synthesis of that dimethyl malonate that we are going to discuss over here. First one, let us see the synthesis of diethyl malonate. First one is the synthesis of DEM. DEM means diethyl malonate. Diethyl malonate, or we can call it as a malonic ester, or we can call it as a malonic ester. Now see here, first one, synthesis of diethyl malonate or malonic ester. And as we know that the active methylene compound means here this CH2 group is known as active methylene compound when it is present in between electron withdrawing group. Here electron withdrawing group, then and then this CH2 group is called as a active methylene group or the reactive methylene group, and those compound containing CH2 group, that compound are known as active methylene compound. And here only at TYBSc level we are going to discuss only two compound. One of them we already discussed, and second one we are just now learning or discussing. So synthesis of diethyl malonate or malonic ester. So let us see here Cl, then here is a CH2, C double bond O, OET. It is known as, what is the let me draw clearly here. Cl, then CH2, then CH2 C double bond O, then here Cl, then CH2 C double bond O, OET. It is known as, in previous case, while studying the acetoacetic ester or ethyl acetoacetate or beta keto ester, the starting compound we have taken is ethyl acetate, 2 moles of ethyl acetate treated with the sodium ethoxide, condensation reaction takes place, and that is a synthetically important one because there is a formation of the new carbon-carbon bond. Whenever in organic chemistry there is a formation of the new carbon-carbon bond takes place, it means that that compound is new one, and therefore its physical properties as well as chemical properties are the different one. Now this one is called as a alpha chloroethyl acetate. It is known as alpha chloroethyl acetate. Ethyl acetate, it will be the starting material used for the synthesis of DAM or the diethyl malonate. First of all, this reaction is carried out in presence of SCN, hydrogen cyanide, or we can use it as a potassium cyanide, SCN or KCN. And now the nucleophilic substitution reaction takes place. As we know that cyanide group is electronegative in nature, it is going to attack over here. If there is a positive and negative, this is going to attack over CH2, and then Cl is departed, and you are going to get here Cn, then CH2 C double bond O, OET. This is the compound which we got over here. Here is a formation of new carbon-carbon bond here, cyanide bond and this carbon atom, and therefore synthetically it is a important one, or it is termed as alpha cyanoethyl acetate. Alpha cyanoethyl acetate, it will be the name of this compound. Now this compound further treated with hydrolysis, as we know that H2O in presence of catalytic amount of acid, or we can use as a mineral acid like as a HCl. What is going to happen? This cyanide group as well as that ester group also get converted into as an acid, and the resulting compound which we are going to get in this particular case is HO, then C double bond O, then middle one is CH2, then C double bond O and OH. If you see this structure, it is just like as a dicarboxylic acid, and as we know that this one is a malonic acid. This is a malonic acid. The name of this compound is a malonic acid. Even though this CH2 group is a active methylene compound, but these proton are, now tell me whether these CH2 methylene proton are more acidic in nature, or the proton which is attached to oxygen atom is more acidic in nature. If you think it, you will find the answer that these are, we generally call it as acid, and therefore acidic proton are highly acidic in nature, and they are the responsible for chemical reaction, and due to this reason most of the reaction are occurred on this carboxylic group than this one, and therefore it require to convert this compound into the next one, what here just treat ETOH in presence of H plus, that is a acid, ETOH in presence of the acid, what will happen here? Ethanol in presence of H plus or catalytic amount of the H2SO4. When you use it, what do you get? This acid group get converted into the ester, and you will get here ETO, then C double bond O, then next one CH2, C double bond O, and then OET, and this is called as a malonic ester. This one is called as a malonic ester, or we can call it as a this is diethyl ether, or we can call it as a diethyl ether, diethyl malone, not diethyl malonate, diethyl malonate. This is a diethyl malonate, and in short we are designating as DEM. DEM means diethyl malonate. So in this way, in the simplest way, we can prepare the diethyl malonate in the laboratory by starting with the alpha chloroethyl acetate. Alpha chloroethyl acetate, as we know that it is readily available in the market. You can treat with the hydrogen cyanide, either hydrogen cyanide or the potassium cyanide. Nucleophilic, it undergoes as a nucleophilic substitution reaction. The resulting compound form will be the alpha cyanoethyl acetate, and that alpha cyanoethyl acetate, there are the cyanide group. It is a very reactive group, and it get hydrolyzed with the help of water in presence of the mineral acid, just like as a hydrochloric acid. That cyanide group get converted into acid, as well as that ester group also get converted into acid, and the resulting compound formed will be the malonic acid. And that malonic acid further treated with ethanol in presence of the catalytic amount of acid, and you will get the required compound or the final product, which is nothing but as a malonic ester or the diethyl malonate. As a synthetic point of view, if you see this compound, this compound is a very versatile variety of the organic compound we can synthesize, we can prepare by using this malonic ester or the malonic diethyl malonate, because there is a CH2 group is present. CH2 group means, as we know that CH2 means reactive methylene group or the active methylene group, because we are learning, we are discussing the active methylene compounds, and this compound diethyl malonate, it is a active methylene compound because it containing as a active methylene group, that is CH2 group, which is high, and it has a 2 proton. CH2, that methylene proton are highly acidic one, and therefore it is responsible for C alkylation, because whenever you use as a base, it can get abstracted and form as a carbanion, and that carbanion can attack on any electrophile nucleophilic substitution reaction takes place, and you will get as a new compound. So monoalkylation, that type of the monoalkylation, dialkylation, resulting into as a formation of the new compound, and that is a next point is a synthetic application of malonic ester. Here we have just discussed the synthesis of malonic ester, how it can be prepared, it can be synthesized in the laboratory, that we have seen over here just by using as a simplest precursor and using the different different reagent, maintaining proper reaction condition, and we get the final product with high yield. Now let us see the synthetic application of, now is a synthetic application of DEM or diethyl malonate, or we can call it as a malonic ester or malonic ester. So let us see the first application which we are going to discuss over here. First one, synthesis of, now is a synthesis of butanoic, synthesis of, first one, propanoic acid using DEM or malonic ester. This is one of the application which we are going to discuss over here. Synthesis of propanoic acid using DEM or malonic ester. So how will you prepare propanoic acid from malonic ester or diethyl malonate? Now see here, in our previous lecture we discussed about the synthetic application of ethyl acetoacetate or malonic, ethyl acetoacetate or acetoacetic ester or the beta keto ester. Different substituted ketone we have prepared. Now by using this compound we are going to synthesize different substituted, mainly as a alpha substituted acetic acid that we are going to prepare here. So let's begin with what are the points we required or we needed for the synthesis of this compound. Let's see. First point required to draw the correct structure of propanoic acid, and you know that prop indicate at 3 carbon atoms. See here, see, you can see clearly there are the 3 carbon atom. I am writing here, I am written here. So prop indicate as a 3 carbon atom, and as we know that OIC acid means there is a carboxylic group is present, and the carboxylic group is always present at the end of the carbon chain. So let's see here, C double bond O, then OH, and while numbering the carboxylic acid, the carbonyl carbon always get the number 1, start from that carbon atom which containing carboxylic group. So give the number first 1, 2 and 3. That's it. Now this carbon atom is a terminal carbon atom which possesses only 1 bond. So how many hydrogen atom I should attach to that carbon atom? 3 carbon atom, right? So that we know that the carbon atom has a 4 valency, and therefore this is a CH3. Now there are 2 bonds, so this carbon atom must possess 2 hydrogen atom. So this is the structure of what we can call it as a structure of propanoic acid. Now, and once you draw this, the structure of propanoic acid, what is the next point needed or required? Planning. See here, Once you do the proper planning, then everything goes smoothly. So now in the planning, I am writing the one of the hydrogen atom in this fashion or in this way, so that you can understood later on shortly why I am making this bond. So now here I am marking this part of the organic compound, propanonic acid. This highlighted part, you remember, CH, C double bond O and OH. This is the one of the part, this part of the molecule, this part is coming from, this part is coming from DAME or diethyl malonate. Remember, this part is coming from DAME or diethyl malonate. Second point will be, see here, this is a methyl group, and that methyl group, here we can write this CH3. This part is coming from, you can write here, this part is coming from where it is coming? What do you think? As usual, while studying the ethyl acetoacetate or acetoacetic ester, we have seen it is coming from primary alkyl halide, right? And we know that the general formula of primary alkyl halide will be the RX. The organic compound which has a general formula RX is known as a alkyl halide. Now here, after finishing planning, it require, next point we are going to study, that is a synthesis, right? In the next one is a synthesis. Once you do the synthesis, they have provided us end product as well as starting material. Start the synthesis from the starting material which is given diethyl malonate or the malonic ester. See here, diethyl malonate, we know that the structure not CH3, what is that? The structure is ETO, then C double bond O, then CH2, C double bond O, OET. This is a structure of DAME, we can call it DAME or diethyl malonate or malonic ester. The step first, as usual, which we are using in sodium ethoxide here. Sodium ethoxide as a base which will abstract the highly acidic proton. We will get ETO, C double bond O, CH minus R, C double bond O and OET. And once you got over here this one, ETO, C double bond O, CH, C double bond O, OET. Finally, what do you get over here? I am clearing this board so that you can see the later part of the organic compound clearly. See this the negative charge present on the carbon atom, that species is known as a carbanion. Here ETO, then C double bond O, CH minus C double bond O, OET. It will be treated with CS3Br, methyl bromide. Then nucleophilic substitution reaction takes place. Negative charge is going to attack on that. CS3Br is departs, so that you will get here ETO, C double bond O, CH, then CH3, C double bond O, OET. This is a compound which we got over here, and after that I am cleaning this board so that you can see properly. Here, next point, as usual, which we have discussed in our previous lectures, then hydrolysis. H2O in presence of EH plus. Hydrolysis is a process where the ester group get converted into acid. That's it. Here you will get HO, then C double bond O, then CH, CS3, C double bond O and H. That is a dicarboxylic acid which we got over here, and after that here just hit it, there is a elimination of carbon dioxide, and that process is known as a decarboxylation. This is known as a decarboxylation, and in the decarboxylation only one acid group get carboxylated in this way, like this, and you will be getting here HO, C double bond O, then CH minus, then we can write here CH3, and then next one just H2O in presence of H plus. What do you get? This process is known as a protonation, and this process is known as a alkylation, and after the protonation, the resulting compound obtains CH3, then CH2, C double bond O, OH, and this is nothing but our target molecule. So in this way we can prepare the target molecule in the laboratory by using the diethyl malonate or the malonic ester. So this is the usual way. This chapter is very simple if you pay the attention from the beginning, and if you remember the step by step, both the synthetic application of ethyl acetoacetate as well as diethyl malonate, one and the same, only the end products are the different, just the steps are involved in this synthesis are very similar one, and if you practice again and again, you will be expert in that synthesis. I hope you will understood this one. In our upcoming lecture, we will discuss the remaining application. Just we have finished only one application. So in our next lecture, we will see the more application. So I think with this, let us stop today here. Remaining we will see in our next lecture. Till then, have a nice day. Thank you.